Good morning and welcome to Motorizing My Uncle Dorkel, and if I'm not mistaken, I think this is going to be part 11. We're starting it today even though we did not get the stuff in yet from Jon in the UK. Jon has run into some problems. He PM'd me after I already uploaded the last video here in my flapping video, chicken video. Anyways, he had to take out the speed control circuitry because trying to slow the I motor down, he blew the chip out. I don't believe in using chips for speed controls. I don't believe in any of this stuff at all. I do it the brute force way. And the way I was originally going to do it is to put a rheostat on the remote and reduce the voltage to his eyes. Now, if I had my shop, there'd be no problem. I could do this, except for my eyesight. That's what's holding me up. I found a few resistors in the junk box that I brought over from my shop, but all my resistors, power resistors, are all put away. Naturally, these resistors are too small. These are 100 ohm resistor, black browns, 100 ohms. And they won't move the I motor at all, but they're too small anyways. They're only 1 watt rating. But I did it just a quick experiment. This coil here, this 12 volt coil in this Guardian relay is DC resistance is 50 ohms. So with 50 ohms in series with the I motor onto a 12 volt battery, which is the battery I told you about that I ordered online, the eyes move slow. They move like this, and I'll show you. They're actually moving at about 4.5 to a little over 5 volts, sometimes almost up to 6, depends on the current draw of the motor. So sometimes it won't start up right away. The motors are 6 volt for the eyes only. The other motors are 12, the other head motor and so forth. That's still too fast, so we want to slow it down a little bit. Now, using this is 50 ohms DC resistance, so I'm using this as a resistor, not as a relay. I'm just using this as a resistor. I'm very, very limited to what parts I have here to work with. So 50 ohms is the absolute max resistance that I could use in this, I think. To get it to go any slower would probably stall out. Sometimes it won't start using this resistor, using this battery. Because originally I used a separate 6 volt battery to run the eyes. But what I'm doing here is trying to use one battery. I'm not quite sure what Jon is doing or has done, and whether he's using 12 volts on the motor or not, because it's really hard because I don't have the stuff in front of me, and I misunderstand some of his things that he tells me. So I'm not sure about that. So not a problem. I could run a separate battery for the eyes only. I got a 6 volt gel cell that I was going to originally use to run just the eyes, which would mean a separate remote wire coming up parallel to his wire. I may have to do that anyways because I'm going to have to use a rheostat, which is going to be heavy wire, probably 18 to 20 gauge at least, so we don't get a big voltage drop. So I'm going to have to make another remote just for the eyes and screw it to the remote that Jon made me. Be a little awkward, but we have to do these things. So what I want to do is to probably get a 100 ohm rheostat, and a 100 ohm rheostat should be okay, but I'd like the eyes to run slower, but there's a stall voltage on the motor. So I really can't experiment because I have nothing else to put in series with this. As you can see, the eyes turned, but not slow enough. But right now, if I start it, you can see the relay kicks in, of course. but the eyes are not going. I don't hear the motor going. But I can bump it with 12 volts. That motor's a 6 volt, although I looked on the uh, American Science website, and it's now listing that motor as 12 volts, but it goes too fast with 6 volts, so we're not going to do it. Now, if you take a look over here, his eyes aren't going, but we are energized. So what we got to do is kick it. So we short out the 50 ohm resistor, which this coil represents. It's going. We're not going to be able to turn that off. We're not going to be able to use any more than a 50 ohm rheostat. Probably, you see, I'm no good at math, so I can't figure things out like this. I do everything in my shop, when I had a shop, all by experimentation. I try this and I try that and I measure current. But give me a formula. I even have trouble with Ohm's law, and I should know that, but you know what? I have an Ohm's law calculator, a round thing that you turn, has a dial on it. It's still hanging in my old shop, and I always refer to that because I can't do the damn math. People may laugh at me about it, but I just can't, and that's why I never got too far with electronics, because it was the damn math that stopped me. Anyways, as I said, I experiment with everything. If I had all my stuff, I had trays of power resistors the size of this box, loaded with power resistors, 30 watts, 50 watts, perfect power resistors. I had some rheostats, but I sold them, unfortunately, but I didn't have very many. So I may have to try my local electronics supply and see if I can buy a 50 ohm rheostat. I don't think I can try 100. I don't think I can try 75 if they have it, or 100 ohm, because the eyes, as you can see, are just barely moving now with 50 ohms on it, and it has to be kick-started by shorting out the resistor here. As I said, the coil is acting as a resistor. That's unfortunately is all I have to work with. So if I short it out and give it a kickstart, she'll go. So you naturally, in order to do that, you turn the rheostat all the way down to 0 ohms, and then when you want to slow the eyes down, you just turn it that way. You can hear that motor going. The voltage is all over the place. Well, it works fine on my 6-volt battery, and it gives 6.2 volts across the motor while it's going. So I think the easiest thing to do, instead of using a rheostat, I think we'll just go with the 6 volts separate from this. In other words, this battery will be dedicated for the eyes only. We'll run another wire up the side of the remote, tape it to the remote wire, and use the buttons there. When I get the stuff, I'll know better what to do. But I did want to give you an update on my circuitry here. I should be able to control the motor with a rheostat. Maybe 25 or 30 ohm rheostat. I just don't want to go out and buy these things and find out they're not going to work. And a rheostat, of course, to handle the power is going to be a little bit on the heavy side. But that's not a problem. If the remote is as big as this meter here, I just bolt it to the side of the one that John made here. These are things I'm just thinking of doing, but I really have to wait for the materials to come in. All right, we'll continue on with this. This is the next day now. Before the stuff arrives from John in the UK, I added this. receptacle. And I mean, I could have gone out and bought probably in the automotive stores, the only place I'd get one, is a panel mount female receptacle, but I figured we'll just use one of these type here. And I'll show you what it looks like when they're not all taped up like this. Of course, this is a better quality one, and I wasn't about to cut this up. But this one has clip leads on it. And I just went through my shed and I dug in some boxes and I found, I knew I had stuff like this. So what I did is I mounted a cheaper one, it'll still function just as good, in here, and put red tape on the positive lead here. And what this is going to do is this will enable me to power up from an external battery, which may or may not ever be needed, but also it'll enable me to plug in a cigarette lighter male plug and charge it using my 1 amp trickle charger. So the battery would be located back here somewhere. I don't really know where it's going to be. It could be over here, it could be over here, because the amplifier that Jon is going to be sending me, he gave me the dimensions of it, and it should fit right in here. I'll have to build this up probably so it'll be level, not a problem. And what I'm going to do is to fuse this, and I still want to put a meter in here to monitor the charging discharge voltage mostly, and the charging voltage of course, but I can add that later on because that'll just go across the battery. But when the equipment comes from the UK, probably going to change this rod to the Acme thread rod that he is sending me, which came from a large C-clamp. And the thing is, I may have to lower this motor because I already lowered it now to make the modification for this particular rod, but if the coupling is too tall here and fat, it may cause my new rod to have to be mounted down here. Not a problem on the bearing end. I can deal with this and drill right through and relocate this down here, or use a completely different bearing, which I think he made up one for me to go in there, and a hose coupling to go to the motor. So it's a 3/8 inch diameter shaft here, this rod. So even if the Acme thread C-clamp rod is thicker, it's not a problem. I use a bigger hose here and then just wrap some tape around the motor shaft and slip it over with some hose clamps that should hold it. But dropping the motor down may be my biggest challenge, because I will have to remove this fuse holder and drop it down. But I'd have to cut into this wood here. It's going to involve some work there. But the safety switch circuit that Jon has designed, the micro switches, is in a complete assembly and will be mounted one switch here and one switch here. And it does matter, although I couldn't figure out why it would matter, but that's why I'm not a circuit designer and Jon is. It's important that the switch gets mounted on the proper side. In other words, you can't interchange them. But I'm not going to even try to figure out why it would make a difference. But anyways, I'm going to show you how fast this head turns. And I'm not going to show you the front of Uncle Dorkle, because there's some cosmetic changes that I want to present when he is completely finished and ready to be doing his skits. But I am going to show you from the back view here how fast the motor turns, even with my old rod, using the new sealed lead acid battery that I got. So hang on just a minute and I'll be right back. It doesn't matter what polarity, of course, because it's going to change it with the direction. But right now, of course, we don't have any of the safety switches in there, so we got to watch the head rotation. But mainly I want to show you it's going somewhat faster because I'm running a good 12-volt battery instead of two 6-volts in series. So here we go. Still turning slow, but somewhat faster than before. I did want to show you that anyways. So this battery's working quite well. And what I want to do is, like I said, of course there's a mess of wires here. That's all going to be, you know, put in their proper place later on. Battery will probably go back in here like this. But the contacts will probably be over on this side. But I'm not sure yet because the battery could go on that side. I'm going to have to add a 6-volt battery for the I motor. The I motor is strictly 6 volts. I could run the I motor on 12, but the I's will go like a bat out of hell here, and they're going too fast now. But anyways, that's the update right now on this, so to speak, until we get the apparatus to go in here. But before the next series comes up for motorizing my uncle, there will be, as I said, an unboxing video when that package arrives from the UK. So everyone, thank you for watching. Stay tuned because there will be more coming. I am sure of that.